Alright, let's have a look at the cumulative distribution function. Now this is an interesting thing. It allows you to use your integrated function to find a probability, and you use the definition of this cumulative distribution function. A cumulative value, so it will be the area underneath the graph in your PDF between 2 points. Okay, now you need to notice the difference between the capital F and the small f, because the small f is obviously your function and your capital F is your integrated function. Okay, so that's the first thing you're going to notice, and watch out for that in exams. And then also you need to be very aware that it's going to be finding your probability of x being less than or equal to a value. Okay, and that's going to be our integral from a value of, say, c to a value of x. So it's between any 2 points of, and we're going to put f of t dt. We just replace our x with a t so that we can integrate and put x in as a variable. Okay, let's do an example of that, and hopefully that'll make a little bit more sense. The time, x seconds. Now time we know is going to be a continuous random variable. So here again you're going to be thinking to yourself, is this discrete? Is it continuous? Okay, so we know that that's continuous. And they're also saying to you that it has a density function. Okay, so we've got a density function, and they're saying it's given by f of x is equal to 5 over x squared for x greater than or equal to 5, and it's equal to 0 for x less than 5. Okay, and they want us to determine capital F of x, the cumulative distribution function of x. Now capital F of x implies that we are going to be integrating. Okay, so we want that our capital F of x is going to be our probability of x being less than or equal to x, and capital F of x is also equal to our integral. Now we're saying 5 from x greater than 5, so it's going to be from 5 to a point x. We don't know what it is, and so we're going to replace our x's with a t just so that we can easily integrate and not get mixed up between the x's and the t's. Okay, so we're integrating 5 to x of 5 over t squared dt, and that's equal to negative 5 over t, and that's going from 5 to x, and we have negative 5 over x, take negative 1, and that gives us negative 5 over x plus 1. So therefore, our integrated function, our cumulative distribution function, is going to be 1 minus 5 over x for x greater than or equal to 5. Now you say to me, what does that do for me? Okay, what that does is that actually allows you to find a probability using that function. You've only got to integrate the once, and you can actually use that function to find your probability. So let's have a look. If we look at B, we're wanting our probability of x being less than or equal to 7. What that actually is equal to is just equal to our integrated function, our cumulative distribution function's value at 7. Okay, because less than or equal to, probability of less than or equal to. Okay, so it's as easy as saying 1 minus 5 over 7, and that's equal to 2/7. Okay, it gets a little bit trickier when we're finding a probability greater than, but remember we have got our complementary function there. So our probability of x being greater than or equal to 6 is actually going to be 1 minus our probability of x being less than 6. Okay, so that's going to be 1 minus f of 6. Remember, in terms of continuous random variables, less than or equal to, less than, same thing, because we don't have an exact value for them. So that's going to be 1 minus 5 over 6, and that will be 5 over 6. All right, and we can even do slightly more complicated ones, because we could do the probability between 10 and 20, keeping in mind that if we're going to draw this on a number line, okay, f of 10 would go up to this point here, and f of 20 would go to that point there. So f of 20 minus 10 would be sitting over here. And that's the difference we're wanting, okay? So we just need to remember it's the larger one minus the smaller one. So we're looking at the probability of x being less than or equal to 20 minus our probability of x being less than or equal to 10. And that means we've got f of 20 minus f of 10. And this is giving your fraction knowledge a really good workout. minus 10, and that's going to be negative 5 over 20 plus 5 over 10, and that's equal to a quarter. Notice all my probabilities are positive. Okay, the Cambridge notes will be on our OneNote, and we'll do an extra example from there in the next video.